we are going to look at some commonly missed concepts on the competency test. So on this first type of problem, if you have something such as x to the 9th, and it is multiplied by x to the 9th times b times c, and that whole product is raised to the power of -5, you have to realize that this power of -5 applies to all terms. So if we simplify that first, I'm going to leave the x to the 9th out here. When you have a power raised to another power, you actually multiply powers. So that becomes x to the -45th. b is understood to have a power of 1. So again, when we multiply, that becomes b to the -5th. c is also understood to have a power of 1. So that becomes c to the -5th. Now, as we go to distribute the x to the 9th, since x's are common bases, when you multiply, you actually add their powers together. So that will become an x to the -36th power. And then we still have our b to the -5th, and we still have our c to the -5th. They do not want you to leave negative powers in your answer. So when we go to simplify, what a negative power does is it simply will put that term, in this case, in the bottom of a fraction. Since there will be nothing left on top, we'll put a factor of 1. And so we have a 1 divided by x to the 36th, b to the 5th, and c to the 5th. So that would be your final simplified answer in that case. Okay, so a second commonly missed concepts was when you were asked to factor something that was a difference of squares. So some of you may have seen something like that. X to the 4th minus 1. So that's called a difference of squares. And when you factor difference of squares, you get two conjugates. So basically, you get, if I take the square root of x to the 4th, I get x squared in each set of parentheses. And then if I take the square root of 1, I get 1s in each set. And one of the factors will have a plus sign, the other will have a minus. Now, the problem is that's where most students stopped. And they did not realize that this factor can be factored again. It is also a difference of squares. So the x squared plus 1, that's as far as we can factor it. But for the x squared minus 1, it can also be broken down into what we call conjugates. So the square root of the x squared would give me an x inside of each parentheses. The square root of the 1 would give me a 1 inside of each parentheses. And then one of the factors has to have a plus sign, and the other factor has to have a minus. So this would be your final answer in terms of final factored form. Okay, let's look at an inequality next and then talk about interval notation. So let's say we had something such as 9 minus parentheses x plus 2, and that is greater than or equal to 7 minus 6x. Now, you're going to solve this just like you would a regular equation, meaning you've got to get all of the x's together. And so the first thing is you would have to distribute this minus sign. So we would have 9 minus x minus 2 is greater than or equal to 7 minus 6x. Now, if I go ahead and combine like terms, the 9 minus 2 would leave me with just a 7 minus x is greater than or equal to 7 minus 6x. So you'll notice that we have x terms on both sides. So at this point, I would want to get the x terms together. So I would probably add the 6x to both sides. And then that is going to leave me with a 7 plus a 5x is greater than or equal to just 7. So now that we have the x's together, we need to get the constant terms together. So we would subtract this 7 on both sides, and I would be left with 5x is greater than or equal to 0. And then my final step here would be to divide by 5. Now remember right there, if you had to divide by negative, you do have to remember to flip your symbol. In this case, we're not dividing by negative, we divided by positive, so we don't have to flip, but that's just a little thing to remember there in case they give you one that does. So I get x is greater than or equal to 0. Now, the problem is some of you express that as your answer. If I go ahead and graph this answer on a number line, because x could equal 0, it would have a solid point, and greater than 0 would be shaded to the right. And so we would describe this interval notation as the graph starts at 0. Since it touches it, we put a square bracket. If it didn't touch it, meaning it was not equal at 0, you would just put a parentheses. And then we put a comma. And because the shading just keeps going and going to the right, we call that positive infinity. And you never touch positive infinity, so you would simply close with a parentheses.